Hey guys, so today we're going to be going over how to solve systems of equations. You're going to use systems of equations in a lot of your problems, whether it be math, physics, or engineering related. And you're going to have to do them manually in a lot of your classes and things like that. Later on down the road, you can use software like for example, I use MATLAB a lot as a mechanical engineer, and you can use that to solve systems of equations for you, or you can use a calculator if you have a nice scientific calculator. But you're also going to need to know how to solve them manually. And the first way we're going to learn how to solve them is elimination. So with elimination, the first thing you're gonna notice, if you can solve it with elimination, is can you eliminate one of the variables right away by combining like variables, the like terms in each equation. If you can't, you're gonna have to use multipliers, and I'll show you that in another example right after this one. But anyways, so to solve elimination, you're going to look at these two equations here. We got 3x plus 5y is equal to 15. That's one equation. 2x minus 5y is equal to negative 5. That's another equation. So with elimination, what we're going to do is add these two equations together, basically, the like terms in each equation. So if you look at it, these two are like terms. So they're both positive, so we're going to add them together. You get 5x. These two are like terms. One's positive, one's negative, so you see that it cancels out. That becomes plus 0y. That's just, I'm going to put that as a placeholder right there. That means nothing. That's 0 right there. These two are like terms. 15 minus 5. That becomes 10, okay? That's our resulting equation. Then, this is 0, so all we have left over is 5x equals 10. Solving for x, dividing by 5, we get x is equal to 2, okay? Then, once we have that x is equal to 2, we can just go ahead and take any of these equations. We can either take this equation or this equation and plug x into the equation and solve for y. So we would have, let's use the first one. So we have 3 times 2, that's our x, plus 5y equals 15, okay? Then, from here, we just go ahead and solve for y. This is 6 plus 5y is equal to 15. Subtract 6, we get 5y is equal to 9. Then, all we gotta do is divide by 5 on each side, and we have that y is equal to 9/5. And that's how you solve systems of equations using elimination, if you can eliminate them out right away. Now, if you can't eliminate one term right away, let's say we got 3x plus 5y is equal to 15. Okay, that's our first equation. And then let's say we have 2x, let's say we have plus 10y is equal to 3, okay? So if you can see here, none of your terms are going to cancel out right away. So what you want to do is look at the equations and say, hey, what can I multiply either of these equations by to make one of the terms match up, kind of like how we had up here in the first example. So right off the bat, I see that, hey, if I multiply this equation times -2, you would get a -10y up here, and you would be able to eliminate this term out. So let's go ahead and do that. So if we multiply this whole equation by 2, so that means we're going to multiply each term in the equation by 2. So we would get 6x, -2 I mean. Yeah, we'll multiply it times -2. -6x minus 10y equals -30. Okay? Then we're going to write the second equation back over here. Okay? So now, if we look at it, these two terms match up with each other. And the reason we can do this multiplying method, is because as long as you multiply every term in the equation by that number, the equation stays the same because you can just divide it back out. I can take this equation and divide it by 2 again, -2, and get this equation back. They're one and the same. So now we would just go ahead like we solved with regular elimination. This would go to 0 because those cancel. -6 plus 2x, we get -4x equals -30 plus 3, -27. Then we just solve for here. Divide by -4, divide by -4. We get x is equal to 27/4. Then, I'm not going to plug this one in, but you would just go ahead and plug this x into either of these two equations and solve for y. And there you have it. That's how you solve systems equations using elimination. Thanks, guys.